Good morning, good afternoon, good evening. I am the Oracle of Chinem Kutu. This question that is here was introduced earlier on as part of a two-question presentation where we worked the first question and then we said we'll come back to this one as the second question. It appeared in the 2012 Matric paper, higher grade paper 1 question as question 7.1, and we are going to be dealing with it as question 7.1. The graph represents the functions f and g, with fx is equal to ax cubed plus bx plus 2 and gx is equal to minus x plus 2. And the diagram here, shows the two functions on a Cartesian plane. We have got the cubic function, which is fx, and it's a x cubed plus bx plus 2. A and b are constants to be found. They are not known as yet. And we have got the line gx, which is equal to minus x plus 2. And you can see here that the line and the function f, both of them meet at 2, and they also intersect at c, and at minus 1, the cubic function f has got a repeated root as it just touches the x-axis at minus 1. So this question had a number of part questions to it, 7.1 up to 7.1.6, 7.1.1 up to 7.1.6. And the mark allocations for each are shown here on the right in red, 1, 5, 4, 5, 3, 2, and the total marks were 20. So you have to realize that these questions, the marks are according to the difficultness of the question that you will be dealing with 1 and 2 being the simplest, and 3 and 4 being the medium difficult questions, and 5 being very difficult questions. So my advice when you get a question like this in an examination, follow through. Start at the beginning. Don't try and rush to the questions with higher marks. You realize that perhaps the step that you didn't do in the first question is needed for you to answer the question with the higher marks. So also, if you get a simpler question and you do it well at the beginning, it boosts your confidence and you can answer the other questions with the added verve because of the confidence that you would have gained from answering the first part of the question. So we are going to answer this question in parts and present it in different video clips, as answering all the questions would make the video very long. So in keeping with our convention of naming questions, this first part which we are going to do for this particular question is going to be called the application of calculus 2, differentiation part 1, and it answers question 7.1.1 and question 7.1.2. So from the onset we have to identify that we have got a cubic function. I have got a tendency of referring to a cubic function sometimes as a quadratic function. So I am putting this on the board. It's a cubic function. If my tongue slips somewhere along the line and says quadratic, please bear with me. I'm referring to a cubic function. So our cubic function is fx, which is equal to y, which is equal to x cubed plus bx plus 2. And our line is gx is equal to y, which is equal to minus x plus 2, and we call this our equation 1, and we can call this our equation 2. And the reason why I'm putting these fx and gx are functional notations, and putting them in y and y is to remind us that the graphs are drawn on the same Cartesian plane. So it's the same y-axis and the same x-axis. So where the functions intersect on the same axis means that the value of y or x at that point satisfies the equations of both the functions. So the first question requires us to determine the coordinates of C. In other words, it needs us to determine the x and y values of point C. Those are the coordinates. When you are asked for coordinates, don't just find the x alone and then say that's the coordinate. No, you have to find the pair of coordinates x and y. And they are saying determine the coordinates of C, the x-intercept of f and g. In other words, they are saying point C is an x-intercept. In other words, that is the value of x for both functions when the value of y is equal to 0. So, from our two functions, we know that our cubic function given by equation 1 has got a and b, which are unknown, and so the easiest function for us to use in order to get the coordinates is the function 2, which is the line. So to get the x coordinate of C, we use the function gx with y equals to 0, since the point is an intercept, an x. You have to specify x-intercept because it could be a y-intercept like 2 on the diagram there. That is a y-intercept, the value of y when x is equal to 0, and it satisfies both the equation of the line and the equation of the cubic function. So then we have y is equal to 0, and so then we can say gx is equal to 0 is equal to minus x plus 2, and we take x to the left hand side, it becomes a positive. We have x is equal to 2. Then using equation 1, with no, it's no longer necessary for us to use equation 1 because we have said y is equal to 0, so our coordinates are done. So then basically what we have to say here is to say, therefore, the coordinates of C are x is 2 and y is 0, and your 1 mark is bagged. So then now we go to question 7.1.2, and question 7.1.2 says, show by calculation that a is equal to minus 1 and b is equal to 3. In other words, they want us to find the two unknowns, the two constant unknowns in the cubic function, and for us to do that, we need to find two equations in the two unknowns. Then we solve those two equations in two unknowns simultaneously in order to get the two unknowns. So here we have already found the coordinates of C. That means those coordinates satisfy both the equation of the line and the equation of the cubic function. So then using fx, which is equation 1, and the coordinates of C, we know y is equal to 0 equals to a bracket x is equal to 2, so it's 2 to the power 3 plus b bracket x is 2 plus 2, and this gives us 0 is equal to 8a plus 2b plus 2. And so we will have 8a plus 2b equals to minus 2. Divide by 2 on both sides, you will get 4a plus b is equal to minus 1, and you call that your first equation. And then if you look at the point minus 1, it is a repeated root, and at that point we know that y is equal to 0, and at the point x is equal to minus 1 is a repeated root, and at that point y is equal to 0, so its coordinates are minus 1 and 0. We use that on the equation 1. So here we can say, using the repeated root at minus 1, 0, we have y is 0 equals to a bracket minus 1 cubed plus b bracket minus 1 plus 2. So we have 0 is equal to minus a minus b plus 2. And this gives us, if we take a and b to the left hand side, we have a plus b is equal to 2. And this gives us, this is equation 3, and this is equation 4, so that we do not confuse the numbering that we have already given at the top for equation 1 and equation 2. So now with equation 3 and 4, we have got our two unknowns, we have got our two equations in two unknowns. So we can say 4a plus b equals to minus 1, that's 3. And then we taking 4, we have a plus b is equal to 2, and that gives us equation 4. Then we solve these equations, the two equations, simultaneously. To do that, we can start by saying equation 3 minus equation 4, and 4a minus a gives us 3a, b minus b gives us 0, and minus 1 minus 2 gives us minus 3, and therefore a is equal to minus 1 as required. And we have shown exactly how that is gotten. Then we use equation 4. Using 4 with a equals to minus 1, we have minus 1 plus b equals to 2, and therefore b is equal to 1 plus 2, which is equal to 3, and we have shown that b is equal to 3 indeed, as required by the question, and part 1 of this question is done. So let us meet again to do part 2 of the question in the next video.